In this video, we'll be looking at how to write an equation to model real-world linear situations and then use these equations to make predictions. Essentially, what we are learning about here are linear word problems. So word problems, real-world situations that can be modeled by a line graph. So let's start by reading through this first example and underlining what we find important. So here this says that the math department sponsors a math family fun night each year. In the first year, there were 35 participants. So that it looks like information to me that is linked. In the third year, there were 57 participants. So again, pieces of linked information. So what I'm noting here is that because both of these pieces of information are linked, that they have to be points. So I'm going to have a point here in red, and then I'm going to have a point here in blue. Now, the first piece I need to determine is which becomes my x-coordinate and which becomes my y-coordinate. And remember, we're always looking for, okay, is there time? And if there's time, that's the x variable. And is there cost? Because if there is a cost, that's our y variable. And what we notice here is that we have year. And year is a type of time. So those years are going to go in for our x variable. So my first point is going to be the first year, so year 1. And there were 35 participants, or people. And then in the second point, I have the same pattern. We have year 3, so I have after 3 years, there were 57 participants. So here, as I make these points, what I'm doing is I'm assigning my x variable to be the time. So x is the year number, and y is my number of people participating, or my number of participants. So now from here, I need to utilize this information to write the equation of a line into slope-intercept form. Now to do that, I need to start by finding my slope, and I'm going to use my 2 points to help me find my slope. So I have x1, y1, x2, y2. So I'm going to take 57 minus 35 over 3 minus 1. 57 minus 35 is 22. 3 minus 1 is 2. And so my slope becomes 11 over 1, or 11. Now I'm going to take this information, and I always start in point slope form. So we're going to put it into point slope form, which is y minus, I need to pick a point, so I'm going to pick this first point here. So y minus my y-coordinate of 35 is equal to my slope times x minus my x-coordinate of 1. So that there is point slope form, and I then need to rewrite it into slope-intercept form. So I start by distributing. I have y minus 35 is equal to 11x minus 11. I then add 35 to each side. So we have y is equal to 11x plus 24. There is my slope-intercept form equation of this situation. Now from here it says, looking at your equation in part D, what does the slope of your line tell you in words? So let's dissect this slope in green here a little bit more. Remember, as we created this, this was 57 minus 35 in our numerator. And these were our number of participants at various times. So really what's happening here is my numerator, where I had the 11, is 11 participants. And my denominator, 3 and 1, were years. So here I had 1 year once I simplified it. So really what this slope is telling us, this 11 participants in 1 year, is really telling us that attendance increased by 11 participants per year. So we can see our slope there. We increased by 11 participants per 1 year. Then finally, the last part here, we're going to use our equation in orange here. And we're going to use that equation to basically predict how many participants will be present during the 5th year. So remember the year up here, up in B, I denoted as x. So this is really saying x is equal to 5, and we're going to substitute it in here to predict how many participants y we will have in the 5th year. So if we substitute, we get y equals 11 times 5 plus 24. So we have 55 plus 24. So essentially what's happening here is in the 5th year, we are predicting that we will have 79 participants. All right, example 2. Mrs. Conway's swim team has hired a personal trainer to run the dryland program for her swim team. The trainer charges $50 for the first 3 hours and then $20 per hour after that. So remember that word per is telling me slope. So here I know that I have a slope value, so I can say my M value is essentially $20 per 1 hour, or 20. And then I can also see that I have a point, and I need to decide how I want that point to be written. Remember, x is typically our time, and y is typically our cost if they are present. So in this point here, $50 for 3 hours, my time is the 3 hours, so I'm going to put 3 hours, and my cost is $50. Now the next part here says, what do x and y represent in the context of the problem? Well, I'm going to look right at my points here. X is essentially the number of hours of dryland that the swimmers have, and y is my total cost. So now from here I'm going to utilize this information to write the equation into slope-intercept form. So here I can see that I already have a slope and I have 1 point. Now remember, we always start in point-slope form. So I'm going to start with y minus my y-coordinate of 50 is equal to my slope of 20 times x minus my x-coordinate of 3. So remember, this is our point-slope form. This is where we always start. Then from here, we're going to rewrite this into slope-intercept form. So I start by distributing to get rid of the parentheses. So I have y minus 50 is equal to 20x plus a negative 60. Then from here, I add 50 to each side. So I end up with y is equal to 20x plus a negative 10, or you can have y equals 20x minus 10. Those are both the same statement, so either is fine. Moving on to part D, this says to look at our equation and to describe what the slope means in words. So here we can see that our slope is 20. We can also go back up here and note that our slope is also 20 up here, and we described it a little bit more in part A. So what this is really saying is that our cost for our dryland trainer increases $20 per hour. That's what our slope is saying. It's $20 per 1 hour that cost will increase. Then finally in part E, it says, how much would it cost to have the trainer come and train the athletes for 26 hours? So here, we need to decide the 26 hours, which variable does it represent? Well, if I look back up here, hours is associated with x, so this is an x value of 26. I'm then going to take that x value and plug it into my equations. So I have y is equal to 20 times 26 minus 10. So 20 times 26 is 520. Minus the 10 tells us that our cost, if we do 26 hours of dry land throughout the season, will be $510. Okay, so here in example 3, it says a cable company charges $44 for basic service. Each premium channel then costs an additional $16 per channel. So if I start by determining what I currently have in this problem, the word per tells me slope, so I know my slope is 16 over 1, or 16. And then from here, well, it doesn't seem like I have a point. This really represents a point. This is really saying that when we have 0 premium channels, our cost is $44. So they've actually given us a slope with the 16 and a point with 0 premium channels costing $44. Remember, cost always goes in our y coordinate spot. Then from here, we're going to write the equation of our line, and we're going to ultimately end in slope-intercept form. So we always start in point-slope form, so we do y minus our y coordinate of 44 is equal to our slope of 16 times x minus our x coordinate of 0. So then I'm going to rewrite this equation into slope-intercept form. So I distribute y minus 44 is equal to, we have 16x minus 0. We then add 44 to each side, and in slope-intercept form we end up with y equals 16x plus 44. So then from here, what we're going to do is we're going to describe what x and y represent in words. So I want to refer back to the point that I created. And my point that I created says that x is the number of premium channels and y is my cost. Then from here I move on to part C, and part C asks me what the slope and y-intercept represent in words. Well, I know that the slope is $16 per channel, so this is essentially the rate at which our cost increases. It describes that. And our y-intercept, which is 44, so that's this point right here, that y-intercept essentially represents the cost when we have 0 premium channels. Then in part D, it says, how many channels could you receive for $80 a month? So here I notice that I have a cost. So this is telling me that y is equal to 80. So what we can do here is we can substitute 80 in for y into our equation. So we take 80 is equal to 16x plus 44. Subtract 44, subtract 44. I end up with 36 is equal to 16 times x. Divide both sides by 16, and what I do know is that 16 doesn't divide into 36 evenly. Essentially what happens is we end up with x is equal to 2.25 channels, which we know that we can't buy a quarter of a channel. So this question is saying how many channels could you receive if you could spend $80 a month? You here would have to round down and say that you could receive 2 channels at most. You don't quite have enough to get that third extra channel. We only have enough for 2 channels. This final part here says how much would it cost for 12 additional channels? Well, additional channels represents x, so here we have an x value of 12, and we're going to substitute that into our equation. So we have y is equal to 16 times 12 plus 44. 16 times 12 is 192. And then if we add on the 44 to that, we end up with a cost of $236 for the 12 premium channels and the basic service together. And our final word problem here, this one says, in the supermarket, each cup costs $4 and each bowl costs $6. If you want to spend exactly $36, write an equation in standard form to model the situation. So I know this is going to be in standard form because this is a cost calculating equation. So write an equation in standard form to represent the situation. Well, I need to think about how cost is calculated. And I know cost is calculated by taking the number of cups I sell and multiplying it by 4. So let's say that x is equal to the number of cups. So in order to calculate my cost of my cups, I would take 4 times x, because it's $4 per cup, and x is my number of cups. Then I'm going to add that together with the bowls. So I have y is equal to my number of bowls. So I would have $6 per bowl times the number of bowls. And those two costs added together need to equal a total of $36. So there's our equation written in standard form. Again, just to reiterate, we have $4 times the number of cups we buy plus $6 times the number of bowls we buy, and that equals a total of $36. Now, down here it says if you purchase 3 cups, and remember from my notes, x is my number of cups. So what this is saying is that x is equal to 3. We want to know how many bowls we could potentially purchase. So we go to our equation and we substitute 3 in for x. So we have 4 times 3 plus 6y is equal to 36. So this is 12. Subtract the 12, subtract the 12. 6y is equal to 24, divide by 6. We essentially find that if we buy 3 cups, we could then buy 4 bowls and still have enough money. Now on the flip side, if we look at part C, this says if you purchase 2 bowls, and remember bowls is my y variable, so this is saying y is equal to 2. So we go to our equation and we have 4x plus 6 times 2 is equal to 36. 6 times 2 is 12, so we have 4x plus 12 equals 36. We'll subtract 12 from each side. So we have 4x is equal to 24, divide by 4. And I find that if we buy 2 bowls, we can then buy 6 cups and spend exactly $36.